Hi folks, I was going to do the problems from our latest cumulative quiz here. This is on 5.6 through 6.2. I'm just going to go through each problem pretty quickly. Hoping that if you have questions, you can pause and look at the video again or send me questions via email. I'm looking at the quiz right here with our honor statement. Problem 1 has to do with this function n of t. N of t equals 400 over 1 plus 39e to the negative 0.16t. And problems A and B ask us to work with that function and to interpret it as well. Let me switch over to the whiteboard camera here, and we'll take a look at that problem. Okay, so problem 1 gives us our formula for n of t and asks us to evaluate n of 0 and interpret this result in the context of the problem. Well, in a really literal sense, n of 0 means plug in 0 for t. That's not what is meant by interpret this result. We want to know what that means in terms of biologists and fruit fly population. So let's evaluate n of 0 first. All we have to do is plug in t equals 0. So if we do that, we get 400 over 1 plus 39, whoops, times 39, e to the negative 0.16 times 0. Okay, all right, well, what happens when we let t equal 0? If we let t equal 0, well, negative 0.16 times 0 is also 0, and e to the 0th power is just 1, right? So any non-zero number to the 0th power is 1. Okay, well, let's just build outward here and figure out what happens to our entire function. If this whole thing is 1, right, if e to that power is 1, then we have 1 plus 39 times 1. So 1 plus 39 is 40, and n of 0 then is 400 over 40, which is 10. Okay, so there we have evaluated n of 0. Well, what does this mean? Let's look back to the original problem. I'll go back to the problem here. Okay, so problem 1. On the basis of data collected during an experiment, a biologist found that the growth of a fruit fly population n with a limited food supply could be approximated by the exponential model n of t, where t denotes the number of days since the beginning of the experiment. So if we're letting t equal 0, right, so t equals 0, that means that we are at the beginning of the experiment, right? So the experiment has just begun when t equals 0. And then n of t equals 10. And n of t, again, back to the problem here, n of t gives us the fruit fly population. Okay, so the interpretation of this problem, very simply, would be that at the beginning of the experiment, the population of fruit flies equals 10. Hard time writing here. So there's 1A. Okay, so problem 1B asks us to evaluate the limit as t approaches infinity of our function n and interpret this result in the context of the problem. So part B, we want the limit as t approaches infinity of n of t. We're going to evaluate that, interpret it. Well, the interpretation, we can start the interpretation right now. We know that t represents time, right? And t equals 0 is the beginning of the experiment. So t approaching infinity, that means something's going to go on indefinitely, right? Or we're going to have some sort of language about eventually something's going to happen to the population. All right, well, let's figure out what happens when we do take the limit of this function as t approaches infinity. So limit as t goes to infinity of 400 over 1 plus 39 e to the negative 0.16t. I'm going to do this the same way we've done other limit problems and complex functions here. And that's just to sort of group things and talk about what happens to each piece here. All right, well, t, t is going to infinity, right? That's where our limit is headed. And what does that mean then for negative 0.16t? Well, negative 0.16t, if t is going to infinity and we multiply by a negative number, well, that expression then would be headed toward negative infinity, right? So this entire exponent is headed to negative infinity. Well, what happens to e to some power as that power approaches negative infinity? Well, e to an increasingly negative power will get closer and closer to 0. So e to the negative 0.16t, that's going to head to 0. Okay? Well, that's probably our biggest piece right there. This entire expression here now is headed to 0. All right? Well, multiplying by 39, something's headed to 0, we multiply by 39, it still goes to 0. Right? So really, we could say this entire section here approaches 0 as t increases. And now we're almost done because we can see what's left in the denominator is 1. So we have 1 plus something that's approaching 0. Well, that limit of the denominator then would just be 1. And the numerator is 400. So the overall function, its limit would be 400 over 1, or just 400. So there we've evaluated the limit. And let's talk about an interpretation. I'm not going to write it. It'll be a little bit longer here. But the first piece is that time's going to infinity. So we should use the language of eventually or in the long run. In the long run, the population of fruit flies will approach 400. That'd be a good answer for what this means in the context of the problem. Okay, moving on to problem 2, we have some indefinite integrals to evaluate here. The first one is 2 over x squared plus 4x over 3. The whole thing is times dx. Sometimes you'll see parentheses, sometimes you won't. It's understood that this entire quantity is times dx. So like we typically do, we have powers in the denominator or square roots or anything like that. I'm just going to write these as powers of x. So we have the indefinite integral of 2x to the negative second power, right? Because positive powers in the denominator are same as negative powers in the numerator. And then 4x over 3. No, it's not important that I do this, but I'll just write it as 4/3 x all times dx. All right, so now we should be ready to take antiderivatives. As soon as I take my antiderivatives, the dx goes away, the integral symbol goes away. We have an antiderivative, and that's also when the plus c should appear. Sometimes if you're looking at how like some of the online solvers do it, they wait till the very end to add c, which is incorrect. As soon as we take an antiderivative, we have a whole family of functions, so that's when the constant should show up. Okay, so the antiderivative of 2x to the negative second power is going to be 2 times x to the next highest power, so negative 2 plus 1 is negative 1. And then the last piece then is to divide by that new power. Well, dividing by negative 1 is the same as multiplying by negative 1, so I can do that simply by just putting a negative sign out in front. Okay, so just to recap how I got that, increase the power of x by 1 and divided by the new exponent. So I divided by negative 1. Had a 2 out in front already, and so first part of my antiderivative is negative 2 x to the negative first power. Okay, second part, 4/3 times x. Well, we're going to increase that power to 2, and then we're going to divide by the new power, so divide by 2. I'm going to do that by just multiplying the denominator of my existing function, or my existing fraction, by 2. That's going to accomplish the same thing. I don't need a separate fraction to divide by 2. Okay? And last thing for me to do here is to add that plus c. And then, although you're not required to do it on exams like this, or quizzes like this, I'm going to just simplify this for one last step. So negative 2x to the negative first power. You could also write that as 1 over x. Either is fine. And then we have 4 over 2 times 3. I'm going to divide the numerator and the denominator by 2 here. And so that would just give me 2/3 x squared plus c. Now, I know that this section has a bunch of problems that people have told me that they just don't feel confident in their answers about. So remember, anytime you take an antiderivative, you can check your answer by taking the derivative of your solution and seeing if it gives you that original function there. So let me just do that as a check. I'm not going to do it for all the problems here, but just because I know it can be tough to be out there working on your own, not knowing if you're doing it right or not, let's see if we've done it right here. So what is ddx of negative 2x to the negative first plus 2/3 x squared plus c? Okay, well, the derivative of negative 2x to the negative first, switch my mind back into derivative mode. So derivative mode says take that exponent, put it out in front as a coefficient, and then we're going to decrease the power by 1. So that would give me negative 1 times negative 2 times x to the negative second power. So that negative 1 came out in front. We have a negative 1 times a negative 2, and x to the negative second. Second term, the 2 comes out in front, right? So the 2 from the exponent comes out in front. We have 2/3 times 2, which is 4/3 x, and that was x squared. It's going to drop down to be just the first power, and then the derivative of a constant is just 0. If we take a moment to simplify this, negative 1 times negative 2 is 2. So we have 2x to the negative second power plus 4/3 x. And sure enough, that matches what we have right here. 4/3 x and 2x to the negative second, that's the same as 2 over x squared. And so we just checked our answer in red here. If you have any sort of high stakes assessment, whether it's a quiz or even a web assign that's going to count as part of one of your exam grades, I highly recommend you do these steps to make sure that you have the right answer. I think particularly for use substitution problems that can be pretty complicated and you might not know if you've made the right choice for you, this is definitely worth the time. It took me maybe 90 seconds here. It might take you a few minutes to do. But if you care about your grade on these sections, it's a really easy way to make sure that you have the right thing. Okay, here's problem 2b. Problem 2b, it just looks complicated. So at the very beginning, we should already know, like, okay, this is probably going to be a use substitution problem. We just don't know any functions whose derivative this is exactly, right? We may suspect it's coming from the chain rule, and use substitution is designed to help us unpack that and figure out maybe where did this come from. So question number 1, what should I choose u to be? If you have some powers of x, like this is a polynomial for x degree 3, here's another polynomial for x degree 2. If you observe that, almost always it's going to be the higher power of x, right? So it's going to be that x cubed, that cubic equation right up here. Sometimes I'll see people who will let x cubed be u. That would be a mistake here. We're ideally hoping that u is going to take the place of like this entire expression here. So if you're choosing between x cubed and maybe x cubed minus 2x and maybe x cubed minus 2x plus 1, by picking the largest or the most inclusive of those polynomials, we'll typically make a good choice that'll work out in the problem with the least amount of steps. So here's what I'm going to try, and I emphasize try because use substitution sometimes has some mistakes. We have to go back and do it again. Let's try u equals x cubed minus 2x plus 1. When I say try, we're finding out whether this substitution will actually make things better for us. Will it make it the problem into something whose antiderivative is pretty easy to find? All right, well, if I did that, if u equals x cubed minus 2x plus 1, then du dx would be 3x squared minus 2. I'm just taking the derivative here. And then du, multiplying both sides by dx, du equals 3x squared minus 2 times dx. All right, so I made my choice for u. My choice for u immediately led me to what du dx would equal and what du would equal in this scenario. This is a result of my choice of u. I'm not like picking new things. I'm not pulling new things out of the equation. This came straight from my equation for u and taking a derivative. Now I zoom out for a minute and say, okay, is this something that I have? Do I have the pieces here so that I can rewrite this integral in terms of u? All right, well, there's u, right? So if I did that, I'd have e to the u. So I'll move this down a little bit. And then 3x squared minus 2 times dx, well, miraculously, not really, because the calculus professor wrote this problem, miraculously, 3x squared minus 2 times dx is exactly what we needed to substitute for du, okay? So this part and that part together, right, those two things together are the same as du. All right, so that means we made a good choice for you. We can rewrite this entire long, complicated integral as a much simpler one. We can write it as the indefinite integral of e to the u, right? That's from right here. This is my e to the u. And then my 3x squared minus 2 times dx. 3x squared minus 2 times dx is the same as du. And notice how much simpler this is, e to the u du, as opposed to a polynomial times e raised to a polynomial. Okay, so now let's take an antiderivative. Antiderivative of e to the u is e to the u plus c. Again, notice as soon as I take my antiderivative, integral sign goes away. The differential du goes away. E to the u is the antiderivative of e to the u. So I've rewritten my function as its antiderivative, and I've added c all in that one step. It's important that those things all happen at that step. And my final step here, since the problem was given to us in terms of the variable x, I'm going to rewrite my answer in terms of x as well. So instead of e to the u is just standing in for x cubed minus 2x plus 1. I still have my constant plus c. One more thing that I would note about how humans solve this problem as opposed to how computers or solvers approach this. If you were to plug this problem into an online solver, it would sort of have this like long sequence of expressions, and it's not really clear the relationship between those expressions. The way that I've written this out, it's very clear like what I did, why I did it, and which things are equal. So I could even improve this maybe a little bit by putting my work here, like maybe over here, to show that the original equation, the original integral, is equal to this new u substituted integral, right? So the way that I've written this shows the connections between each step. It's not just like a list of steps. That's one of the things that we're looking from you guys, that you understand not only like what is the next thing to do, but what is the relationship between each one of these expressions. The antiderivative of e to the u du is e to the u plus c. We substitute for u is equal to x cubed minus 2x plus 1. And so here is our final answer. Okay, on the problem 2C, another u substitution problem. Do this one a little bit more quickly, less commentary. So x squared minus 1 and 3x. I'm going to choose x squared minus 1 as my choice for u. So sorry, if we have u equals x squared minus 1, then du dx would equal 2x, just the derivative there, and du equals 2x times dx. I'm just going to multiply both sides by dx there. So 2x dx. All right, this is the point where we look back and say, all right, do we have this? Well, I have a square root of u right there, and I have a 3x dx, and I wanted a 2x dx. Okay, well, I can either mess around with my integral by multiplying and dividing by the same number, or I can pretty quickly rewrite my equation for du so that I can do a substitution. I don't want 2x dx, I want 3x dx. So how can I do that? Well, if I divide both sides by 2, first of all, then I have du over 2 equals x dx. Okay, that's nice. That's almost what I have here. In fact, I could substitute for x dx, leaving the 3 there. Or with one more step, if I multiply both sides by 3, I have 3 halves du equals 3x dx. And 3x dx is exactly what I have in my original integral here. Okay, so that's good. So that means I can rewrite my old integral of x as a new integral of u. All right, well, I have the square root of u, right? That's what this part right here turned into, square root of u. And then I have a substitution that 3 halves du equals 3x dx. So 3x dx, we're going to substitute in 3 over 2 du. I noticed the video is lagging. I think my battery's low. I'm just going to pause and plug in my computer so I don't have any more issues. Okay, so I've now rewritten my integral in terms of u. It looks a little bit simpler here. I can factor that 3 halves out in front. So 3 halves times the integral of u to the 1/2 du. And now I'm ready to take an antiderivative. So 3 halves, power of u will increase from 1/2 to 3 halves. And then when we do that, we also have to multiply by the reciprocal of that new power. So we multiply by the reciprocal of 3/2, which is 2/3, and add a constant. And now finally, our final answer here should be in terms of x. You're not required to simplify, but this one simplifies pretty nicely. 3/2 times 2/3, that's 6/6. Those two fractions just cancel to 1. And so what we end up with is x squared plus 1 to the 3/2 power plus c. And that's our final answer. Okay, last problem in this section, part D. We have the integral of 2x squared over 3x cubed plus 2 all to the 3rd power dx. Again, a use substitution problem. We're looking for the higher power of x. We have x cubed inside the parentheses here. We have x squared up top. So I'm going to try, do it over here. So let's try u equals 3x squared plus 2. Okay, so if u equals 3x squared plus 2, then du dx is going to be 6. Sorry, that's a cubed, isn't it? 3x cubed. So if u is 3x cubed plus 2, then du dx would be 9x squared plus 0. And multiplying both sides by dx, I have du equals 9x squared dx. Okay, so I'll pause, look back here, zoom out, say, what do I have? Well, if I commit to that u substitution, I'd have a u cubed in the denominator. And up top, I have a 2x squared dx, which is almost what I have here. I have 9x squared dx. So let me see if I can adjust the coefficient here so that it matches the problem. So I want to turn a 9 into a 2. I can do that by dividing by 9 and then multiplying by 2. Right? So if I take my equation here and I divide by 9, multiply by 2, divide by 9, multiplying by 2, that's just multiplying by 2/9, right? So 9x squared dx times 2/9 equals du times 2/9, right? And 2/9 times 9, those cancel. And so we have 2/9 du equals 2x squared dx. And we're ready to do our substitution then, right? Because we have 2x squared dx. That was a little bit too quick for folks. You could think of this in 2 steps, dividing both sides by 9 in order to get x squared dx, and then multiplying both sides by 2 in order to get 2x squared dx. I did those as a simple single step, multiplying by 2/9 instead of dividing by 9 and then multiplying by 2. Okay, so now I'm ready to rewrite my integral. So my original integral then in terms of x, we can rewrite in terms of u. When we do so, our 2x squared dx, as previously mentioned, becomes 2/9 du. So 2/9 du times 1 over u cubed. So 1 over u cubed is u to the negative 3rd power, right? This is a little bit of a weird way to write it. Almost always we have that du at the end. So I'm going to do a couple things when I simplify this. I'm going to pull that 2/9 out in front and just have it as the integral of u to the negative 3rd du. Right, and that looks like something we can do. That looks like a basic antiderivative problem. So then our answer, still got the 2/9. The power of u is going to increase from -3 to -2. Right, that's what happens when we add 1 to the power. Finally, we're going to multiply by the reciprocal of the new power. So we're going to multiply by the reciprocal of -2. So -1/2 and add c. Okay, so just doing a little bit of simplifying here. If we take 2/9 and multiply by 1 over -2, right, fractions just multiply straight across. And so we have -1/9 times u to the negative 2nd power. Well, right, we want to rewrite this in terms of x for our final answer. So 3x cubed plus 2 to the negative 2nd power plus our constant. There's our final answer. And we can check that by taking a derivative. I'll do that for this last problem just because it's a pretty complicated u substitution problem. So what is d dx of -1/9 times the quantity 3x cubed minus 2 to the negative second power plus c. Okay, well, to take this derivative, we'd have to use the chain rule, right? So the chain rule would say that our derivative is negative 1/9. It's already there. Times, okay, well, we're going to take this inside function 3x cubed minus 2. We're going to take, we're going to drop that power down by 1, right? So negative 2 minus 1 is negative 3. The negative 2 would come out in front, so that's times negative 2. Finally, chain rule says multiply by g prime of x, multiply by the derivative of the inside function. And the derivative of the inside function would be 9x squared. Okay, so what does this give us in the end? Well, we have a let's take care of all the constants first. So we have here negative 1/9 times negative 2 times 9. Right, that's all our constants. Then we have a 9x squared, right? It's being multiplied by. And then we're multiplying by 3x cubed minus 2 to the negative third power. So that would be just the same as 3x cubed minus 2 to the third power in the denominator there. Oops, sorry, no, we're running out of room on the whiteboard here. Actually, really just on the camera. All right. Okay, well, let's see what we have here. Negative 1/9 times 9 is just negative 1, right? And negative 1 times negative 2 is positive 2. So all of our coefficients here would cancel out. Oh, I already took that 9, right? I pulled that 9 out right when I did this multiplication here. And so that would just leave us with a 2. So 2x squared over 3x cubed minus 2 to the third power. That's exactly what we had here. Okay, so a little bit of a more complicated chain rule use substitution problem. Okay, I'm going to take a look at problems 3 and 4 here. Let me just take a look over at the original assignment here. So problem 3, during a thunderstorm, rain is falling at a rate of r prime of t equals 8 times the square root of 2t minus 32t cubed inches per hour, where t ranges in between 0 and 0.6. So problem 3 asks us to give the total amount of rainfall, given that the total amount of rainfall at t equals 0 is 0, find the function giving the total amount of rainfall after t hours. This is a classic example of what we call a differential equation, an equation involving derivatives, right? So they've given us an equation for r prime, and really what they're asking us to do is come up with a function r. Given r prime, let's find r. To go from a derivative to an original function, we're going to have to take an antiderivative. There's going to be one extra step here, and I'll talk about that when we get to it. So if r prime of t equals 6 times the square root of 2t minus 32t cubed, the first thing that we can write here is just that our function r that's going to give us the total rainfall is going to be the antiderivative of r prime of t dt. Right, that's our strategy for solving this problem here. R prime of t is given to us. I'm going to rewrite this very slightly. I'm going to rewrite it as 8 times the square root of 2 times t to the 1/2 power. Right, I'm splitting the square root. It's joined via multiplication, so this is the same as root 2 times root t. We can't do that with addition or subtraction, but we can do it with multiplication and division. I'm going to do that just so that our power of t is separate from this constant multiple here. It's going to make our life a little bit easier. If I did the problem the way it's written here, I'd have to use maybe chain rule or use substitution to make sense of that first term. And then we have minus 32 t cubed dt. So I can take antiderivatives here. So constant multiple rule, I'll take that 8 root t out. And t's power is going to increase by 1, so t to the 3/2 power, and then multiply by the reciprocal of that new power, so multiply by 2/3. It's the antiderivative of my first term. Antiderivative of my second term, well, I have minus 32 as a constant multiple. T cubed is going to bump up to t to the 4th power, and again, I'm going to multiply by the reciprocal of that new power, plus c. That plus c is going to be very important in this problem, because when we take an antiderivative, we get a whole family of functions. We get infinitely many functions whose derivative are equal to r prime here. There's only one function r that we really want, and that's the one that matches the initial conditions that we have been given. So let me just simplify this very slightly, and then we'll take a look at the problem with that initial condition. So let's see, I have 8 root 2 times 2/3. So let me just write that as 16 root 2 over 3 times 3 t to the 3 halves. That's my first expression, just simplified. Minus, well, 32 times 1/4, we could simplify that. 32 divided by 4, I believe, is 8. So minus 8 t to the 4th plus c. Okay, let's pause here and look back at the original problem. So the original problem says, given that the total amount of rainfall at t equals 0 is 0, find a function given the total amount of rainfall after t hours. So the way that I would interpret that is that r of 0 equals 0, right? If r is the total amount of rain, then r of 0 equals 0. So if r of 0 equals 0, well, that means that when we plug in t equals 0 into each one of these expressions, we should get an answer that equals 0. So when I do that, well, any power of 0 is 0. So we have 0 minus 8 times 0. Okay, that's still 0 plus c. Right, now c is the constant that we didn't know. And based on the fact that r of 0 has to equal 0, we can solve this equation for c. And in this case, it's very simple. C equals 0, right? And so our final answer is going to be a function. We want to make sure we write it that way. R of t equals 16 root 2 over 3, t to the 3 halves, minus 8 t to the 4th. And I don't have my plus c, or really I do. My plus c is plus 0. And so my final answer here indicates the value for c that we solved for there. You'll see other initial value problems where that constant is going to be something other than 0. For example, if the initial amount of rainfall was 1, well, then we would have had r of 0 equals 1, and we would have a different value for c when we solved there. One thing that's important, you can't just go from this step here just to our answer. The fact that c equals 0, we didn't assume that. We didn't leave out a c. We put in a c as soon as we took the antiderivative, and we kept it there until we were able to solve for what constant c equaled. And in this case, c was 0. Okay, last problem on this quiz here. Again, let's look back on what the problem was originally written as. So here, find an equation of the curve f of x whose tangent line has slope of f prime of x equals 6x squared minus 4x plus 3, given that the point 1, 2 is on the curve. All right, so if we just sort of summarize what information has been given to us in the problem, just like problem 3, they've given us the derivative of a function, and they've also told us one additional piece of information that we could call an initial value. Or more specifically in this problem, they've located a point on the curve. If you think back to graphing lines, if I just told you that the slope of some line is 2, that's not enough information to draw the line, right? You know how steep the line is, but you wouldn't know where to place it. You'd want the y-intercept or another point on that line. And if I gave you that information, you'd be able to graph the line, and you know exactly what line I'm talking about. Well, problem 4 is very similar. When they say f prime of x is 6x squared minus 4x plus 3, that's information about the slope of the tangent line, right? It's information about the derivative, and there are going to be lots of functions whose derivative equals this. They're going to be similar in some respect, but there's infinitely many of them, and we can't pick a single one because we're going to have that constant plus c in our antiderivative. However, if we're given that the point 1, 2 is on the curve, that's going to narrow it down from infinitely many possibilities to just a single curve that can fulfill this information here. So I've copied that information onto the whiteboard here. I'm going to start by taking an antiderivative. So we know that f of x has to be the antiderivative of f prime, right? That's how we're going to get our function here. And so that would be the antiderivative of 6x squared minus 4x plus 3 dx. Antiderivative is not a hard one here. So let's see, we're going to increase our power to 3. So we have 6x cubed to multiply by the reciprocal of that new power, so times 1/3. minus 4 times, okay, increase the power of x by 1, so x squared, multiply by the reciprocal of that new power. And finally, antiderivative of 3 is 3x plus c. Okay, so here's my general antiderivative. This is a family of functions. I am going to simplify a little bit just for my own benefit in working on this, not because I need to do that for my final answer, but like 6 times 1/3, that's 2, right? So 2x cubed, negative 4x squared times 1/2, so that's minus 2x squared plus 3c, plus 3x plus c is our expression for f of x. Okay, so again, this is a family of functions. We can let c equal 1, c equal 10, c equal million, c equal negative 50. These are all functions whose derivative will be exactly what was given to us. However, only one of them will fulfill this initial condition that the point 1, 2 is on the curve. And really what this means, when we say the point 1, 2 is on the curve, that means if we let x equal 1, then y equals 2. Or more specifically, it means that f of 1 equals 2. So we're going to use that information now to solve for c. So f of 1 equals 2. So the y value would be 2 if we let x equal 1. So 2 equals 2 times 1 cubed minus 2 times 1 squared plus 3 times 1 plus c. Right? So right here, this is our f of 1, which we know to equal 2. And what we've done over here is let x equal 1 in every occurrence of the variable. So let's now solve this for c. So 2 equals 2 minus 2 plus 3 plus c. So 2 equals, well, these will cancel. 2 minus 2 is just 0. 2 equals 3 plus c. And if we subtract 3 from both sides, we get negative 1 equals c. Right? So this is all solving our initial value so that we could come up with our final answer for f of x. So our final answer then, f of x equals 2x cubed minus 2x squared plus 3x minus 1. All right, so to finish the problem there, I've just replaced my constant c with negative 1. Okay, so that's the last problem on this quiz. Hopefully this has been helpful to you. If you have questions about any part of this video, feel free to leave a question either in the discussion forums on D2L. You could do it as a comment to the YouTube video as well, or send me an email.